Okay, now let's work on the practice problems. You're going to need this sheet right here. If you don't have this, it's on Canvas, and we're going to use this as our cheat sheet to do these calculations. Now let's look at 1A. It says calculate the pH of a 0.001 molar HCl solution. So the first thing we want to do is we're going to decide, is this an acid or a base? And we know it's an acid because it starts with hydrogen. We learned this in the last unit. If I know the molarity, and we know molarity also, we've done that before as well, that's the concentration of my acid. So if I'm measuring the concentration of an acid, what am I actually measuring? I'm measuring the amount of hydrogen ions in solution. Okay, and if I want to calculate the pH from that, what do I need to do? It says right here, follow the arrow from hydrogen to pH. It says I take the negative log of my hydrogen concentration. And that's exactly what we're going to do on this calculator. I'm using an old calculator, so if you're at home, you'll be able to do this with this calculator. Okay, so we're going to put this in. We're going to take the negative log of my concentration, and that will give us the pH. So that's exactly what I'm going to type in this calculator here, and I hope you can see it. I'll hold it up a little bit. Okay, we're going to take negative, and then we're going to do the log button. Right here, the log button is here, and I'm going to put in my concentration, which is 0.001, and close my parentheses. Everybody see that? Negative log 0.001. And I'm going to hit enter. Okay, and there's my answer, 3. So the concentration is 0.001. That gives us a pH of 3, which would make sense because we know an acid has a pH below 7. All right, using our same chart, we're going to find the pOH. What is the pOH of this solution? So here's what we know so far. We know the hydrogen concentration, we know the pH, and we want to know the pOH. So following the arrow, it says take 14 and subtract the pH. So that's exactly what we're going to do. 14 minus 3 equals 11. So that is the pOH of the solution. Now, what are we going to do? We're going to find the hydroxide ions in solution. Okay, so let's look at our chart again. We're going from pOH to hydroxide. So we're going to do 10 to the negative. This is a negative pOH. Now, you should have a button on your calculator, whatever calculator you're using, that says 10 to the x. This is what we call an anti-log. So it's usually the same button you use for log. So let's look at this calculator I have right now. Notice if I see the log button right above there in blue, it says 10 to the x. Some calculators, these are reversed. So whatever calculator you have, look at that and see what you need to do. So this is telling me that I'm going to go 10 to the negative pOH. What was my pOH? It is 11. So I'm going to do second log. Okay? And then I'm going to put in negative pOH. So I'm going to put in a negative 11, close my parentheses, and hit enter. What do I get? Now, I don't know if you can see this very well, but it's telling you it's 1 times 10 to the negative 11. Some calculators will have an E, remember that? So I'm going to write 1 times 10 to the negative 11. Everybody following along? Okay, let's go to number 2. It says calculate the pOH of an NOH solution that has a pH of 8.5. So again, let's determine we have a base, it ends in hydroxide, and we're going to calculate the pOH, and we know the pH. So again, I know the pH, I want to know the pOH, so I'm going to do 14 minus the pH. So 14 minus 8.5, and we're going to use a calculator, subtract, and we're going to get 5.5. So there's our pH. No, our POH, sorry. So we know the pH, the POH, and again, we want to find the hydroxide concentration. So what is that? That is the 10 to the X, okay? That's this 10 to the X button. We're going this way again, so we're going to go 10 to the negative POH. Okay, 10 to the X button. So I'm going to clear this out. And we're going to go second log, and we're going to put in our number, which is 5.5. So negative 5.5. Enter. Ooh, we got a big giant number there, right? We want that in scientific notation. Okay, so instead of writing that number out, what are we going to do? We're going to do 1, 2, 3, 4, 5, 6. I'm going to move it behind my first non-zero number, which is my 3. So I get 3.162 times 10 to the what? Well, I had to move that how many times? 6 times to get back there. So that would be negative 6 because that number is less than 1. All right, are you with me? Now we're going to find the hydrogen ion concentration. All right, well, let's go back to our chart here. So we know quite a few things at this point. We know the pH, we know the POH, we know the OH. So we can go from here to here, right? Or we could go here to here. Either way. Okay, so if we're working with numbers in scientific notation, we have to use that EE button. Let's recall that also. Every calculator is a little bit different. So if you need to find your EE button on your calculator, you can do that right now. Okay, on this particular calculator, let's find it here. The EE button is in blue above this button here. So that means I have to hit the second button to get there. Okay, so if I'm going to use this formula right here, I'm going to type this in my calculator using the EE button. So I've got 1, and then I'm going to go second EE to the negative 14. Okay, you see what that looks like? Oh, can't see it, sorry. All right, and then what are we going to do? Exactly what it says on here. We're going to divide by, so we're going to divide by, and then we're going to use the concentration that we got on our last problem. And what did we get? We got 3.162. And again, we need the EE button. So I'm going to go second EE, and what was our exponent? Negative 6. And I'm going to hit enter. What I get? Oh my goodness. Okay, so again, not in scientific notation, but that's okay because we know how to put numbers in scientific notation. So I know I have 3 times 10 to the something. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times to get behind the 3, so negative 9. All right, everybody with me? Okay, let's go to more practice. All right, next one says, what is the pH and POH of a 1.2 times 10 to the negative 3 molar HBr solution? So again, what are we going to do? HBr is an acid. So if I know the concentration of my acid, where am I at? I am right here, molarity of my acid, and I want to know the pH. So I do exactly what it says, negative log of my concentration. So let's do that again. Let's clear out our calculator, and we're going to go negative log. And what's my concentration? 1.2. And again, we're going to use that EE button to the what? To the negative 3. negative log of my concentration. Enter. There it is, 2.92. That's your pH. Now I want to solve for POH. Oops. POH. And to do that, it says I'm going to take pH and go to POH. I'm going to do 14 minus pH, so 14 minus 2.92. So clear 14 minus 2.92, and there's my pH. POH, sorry, 11.08. Okay, if you have a different calculator, you can send me a message or ask me how to use a different calculator. I want you to practice using this one. Answers to this are on the PowerPoint, and good luck.